Eaton products end up in pretty much anything that you drive or live in. They have an insane amount of products in their portfolio, and they need somewhere to test them. That is why we have come to Marshall, Michigan to visit Eaton's proving grounds, where they test total vehicles and also sub-level components before they enter into series production vehicles. In this episode, you are going to join me inside of the labs at their proving grounds, where they are stress testing DC to DC converters, inverters, a bunch of other high voltage electric vehicle componentry before they actually go to series production. It's a really cool peek behind the scenes of some of the testing that happens in the automotive industry. We're also going to, later on in the video, look at their insane differential testing labs and supercharger labs, because of course, Eaton doesn't just do electric cars, there's some combustion stuff going on there, and I thought it would be really interesting for you guys just to see the labs later on in the video. Of course, if you're interested in a full tour of the Eaton proving grounds, I already have shot that. It's going to be linked in the description below, but for now, we are going to go super nerd out with Eaton at their proving grounds, seeing how electric vehicle subcomponents are tested. Thank you to our sponsors for today's video: Eaton, Ionna, InfyPower, and Nokian Tyres. This video is brought to you by Eaton. Eaton is a one-stop shop for implementing reliable and innovative EV charging infrastructure at your site. Across all applications, Eaton's EV charging infrastructure, hardware and software gives you the scalability, flexibility, and intelligence you need to charge today and scale up tomorrow. Learn more at eaton.com/EVCI. This video is also brought to you by Ionna, North America's premier charging network. With unmatched commitment to elevating the customer experience, Ionna is opening America's roads to all EVs, giving drivers the coverage they need, the reliability they deserve, and the amenities they crave. And Nokian Tyres, a leader in safety and sustainability. The latest generations of Nokian Tyres products come with the Electric Fit emblem that certifies they're a seamless fit for electric vehicles. And most of those all-season and all-weather tires come from Nokian Tyres' award-winning factory in the United States. Learn more at nokiantyres.com/EV. Hello and welcome to another Out of Spec Reviews video. If you've seen any of our videos, you have heard the name Eaton, as they are one of our great sponsors that plays at the beginning of the videos. Well, today they've invited us up to their racetrack, if you will. It's sort of a durability and proving grounds here in Michigan, and attached to their track facility are a bunch of laboratory space. We're talking engine dynos, a bunch of cool stuff, and both on the e-mobility side, but also the old combustion world. So you guys love it when we go on factory tours. We're able to bring you behind the scenes of the auto industry, both at final vehicle assembly, at subcomponent manufacturers, things like that. But we are going way early in the process to discuss everything Eaton has to offer here at the proving ground. So this is going to be focused on a lot of differentials, inverters, DC to DC components, charging components, but also on the combustion side, camshaft situations. There's diesel engine tech in there for commercial applications. It's really cool. So it's not all going to be electric focused in this video. I'm going to put all the EV stuff up front. We're going to start with their e-mobility thing, since that's the main focus of this channel. But I think a lot of you guys are also just interested in how things are made. So you can join us as we go on a full tour of the laboratory space here at the Eaton Proving Grounds. So you guys join me at the entrance to the Eaton Tech Center right here at the Proving Grounds, and this is the car that I've been driving. I actually went to Avis and rented a Tesla Model 3 online, and they were like, how about an F-150 Lightning? And I was like, hell yeah, that's sick. Let's do it. So that's really cool. I'm going to have a full tour of the facility on probably my personal channel, just called Kyle Connor, where you can see the track space. There's 620 acres, very similar size to the new out of spec track in North Carolina. And they've just used it wonderfully. There's a lodge here on site that we were able to stay at, and it's really, really cool. This is their shuttle to get around the proving grounds. But today we're discussing more componentry, more testing, validation, certification. For example, if a differential breaks in a series production car and it comes in for warranty work, they can actually see exactly what's failed, It's really cool. And then, so this is the entrance to the tech building. Timon, Sam, Scott, they've all joined me here. Everyone's working on getting videos up for you guys right now to watch. A lot of valve train components happening here. You're going to see some, differentials. Of course, this is a really cool style differential, and they have these nice, well, I don't have two hands free, but cool interactive displays to show how all the differentials work. These are valve train actuation situations, similar to like cylinder deactivation or engine brakes, for diesel applications, things like that. That's the type of combustion stuff we're going to get into, and it all happens when you go in through this door. You go to the left and you get all the electric mobility space. You go to the right, you get all the combustion space. We're going to start over here to the left. They actually gave me a badge, crazy enough. I put it right over here to get inside of their building, which is super cool. So I can come here and tap this, and we're in, which is great. And then all the fun starts as we head down that way. So let's go pick up the video over here with the electrification situation. And we're going to learn all about chargers, inverters, DC to DC situations, contactors, bus bars, fuses, etc. Should be a great nerd video for you guys. Hey guys, this is Mark. Mark, welcome back to the channel.
Thanks for having me. We're here in Marshall, and we're going to talk about some of our power distribution and protection products.
Yeah, so actually, before we even get into that, Eaton offers a ton of products, both on the ICE side and EV side.
That's right.
Your responsibility now is mostly on the EV side.
That's right. Mostly mobility, yep.
What is your responsibility?
So I am the Global Product Strategy Manager for our power distribution and protection products. So that includes about half of what we've got on the table here.
And it's really cool. We always get to talk about the car industry when we get
Yes.
together. You spend a lot of time, overseas as well, learning about foreign car companies.
Yep.
And, Mark's really got his finger on the pulse on what's happening.
Yep, my role is really to keep track of what the OEMs are doing and making sure that our product roadmap lines up with what our customers are looking for.
Totally. So there's some cool technologies that you've had for some time and some new stuff that we're going to look at down there. So walk us through exactly what Eaton offers for electric cars.
Perfect. Yeah, so we'll really start with the foundation within Eaton's portfolio is that we are a fuse and circuit protection company at our core. And this goes across EV industry into the electrical sector. DC and AC circuit protection is our core competency. So on the board here we have our line of Bussmann EV fuses. So these are commonly in most OEMs at this point have used Bussmann fuses in some application or another. We also have pyro fuses. We have a unique thing called a dual trigger pyro. So there is a concept that we kind of keep track of within the industry of passive protection and active protection. So the vehicle wants to be able to protect itself when it needs to, but it also needs a backup plan of how am I going to protect myself if my battery management system or something goes to sleep. And so typically fuses are really great at the passive protection, but they come with a resistance penalty and some degradation in lifetime. Pyro fuses are great at the active protection, but they require software and something to tell them what to do. The dual trigger kind of takes the best of both worlds, so you get the performance and the low resistance of the pyro fuse, but it has a backup plan. It has the ability to self-protect even if your BMS goes to sleep.
And we should mention BMS go to sleep for many reasons, many of which is like phantom drain.
Exactly.
Yeah.
You can't have it running all the time. Yep. That's exactly right.
When the car's asleep, if there's nothing software-wise to tell the pyro fuse to go,
Yep.
then it could be a bad situation.
Exactly. So typically your contactors are open, so your battery is in a safe state. But there's always a window in between when if you lose 12-volt power, your battery management system might go to sleep, and your contactors have not completely opened yet. So how do you manage your protection through that state? Or maybe it's an edge case, maybe it's not. These are the things that we work with directly with the OEMs to make sure that we're covering them in all of their cases.
And when you're building millions of cars and they're going all around the world, things happen.
That's exactly right. Yep. So we then kind of have the ability to put our fuses inside of boxes throughout the vehicle. So this is an auxiliary power distribution unit. You'd see it in commercial vehicles heavily. You see it in some passenger cars. This comes out of a North American application. The next product is really our signature product for the EV space, which we call BrakeTor. So this is a combined switching and protection product. I know we've featured it in some of our videos before.
Yeah.
So it is the primary on-off switch for the battery pack, as well as the protection system for the battery pack. It has fuse or current limiting properties like a thermal fuse, but it also has the active actuation like a pyro. So it can take everything on the board over there, put it into a device similar to a contactor. And it can be the primary switching and protection device within the battery pack.
And there's some cool features to that as well. You know, for example, a lot of times if the airbag's deploy in a car, or even if there's a really bad accident,
yes,
the pyro goes in the battery.
Yes.
Can never be started until the battery pack's
That's exactly
dropped.
right. Yep. So you know, you want, when something goes wrong, to isolate the battery quickly. This is where a pyro comes in, but as you said, now it's a service event. The BrakeTor has the ability to break and make load connections under load a huge number of times. So you have the ability to reset the vehicle in case of something like that. And this is particularly important in the commercial vehicle space where you have multiple battery packs.
Right.
So each one would have a BrakeTor inside of it. And if maybe the vehicle goes down for some reason, you're not having a service event on 6 battery packs.
Right, that makes a lot of sense. That's really interesting.
Yep. So all of these products get integrated into what we call the battery disconnect unit. It also could be called the high voltage junction box or a bunch of other names. So you'll see a combination of switching and protection products. So it could be fuses, it could be BrakeTor, it could be pyro. There are high voltage contactors as well that would be used in conjunction with that. So we're really bringing the power into the in and out of the battery pack and managing that system. Our newest product that we're really excited about is called the battery configuration switch. What I'm showing here is our B sample. So this is under development currently, but you can see it's a device that goes inside the battery disconnect unit to perform 400 and 800 volt switching for DC fast charging. So when you pull up to a 400 volt charger, like primarily Tesla Superchargers, an 800 volt vehicle can't interface natively with that product. So what you have to do is either boost that voltage up, and that can be expensive and lower power, or you split your battery pack in half, and now you can natively interface with the charger.
Right, and this is the ka-chunk that you would hear essentially.
That's right. Yeah.
That would split the battery from a series to parallel configuration.
It can be done with traditional contactors, but that has an inherent safety fault. Flaw where if all 3 contactors that are done for the switching close simultaneously, it's shorting out your battery pack. So the key safety feature of a product like the battery configuration switch is that it can it is mechanically impossible to put it in that fault condition. It is either in position A in series, it is in position B in parallel, or it is in between, held in a safe state that can isolate the 2 halves of your battery pack.
Makes sense. Very cool. That'll be a neat product, and I think should be pretty popular.
That's right. Yeah, we're getting a lot of interest from a lot of OEMs. Anybody that's looking at 800 volts needs to solve this problem, and we think this is the most cost-effective and safest way to do it.
Yeah, I've heard a couple cars maybe coming to market that don't have a way to interface with 400 volt chargers, which is just not acceptable.
That's exactly right. Yeah, you have to think about it of, even if your user rarely charges, maybe the only fast charger that they have access to is 400 volts, and you can't sell them a car that is not usable on road trips.
Totally agree. So then what do we have here? I'm seeing big MCS connections. This is big power stuff.
These are the big boys. So these are commercial vehicle megawatt charging boxes. So we kind of got 2 varieties. One is the lower power. This would be for more of
that's quotations. Can we?
Yeah, lower power, only 800 amps, sub 1 megawatt. But getting that mega MCS interface in the vehicle. But this one is the one that we're most excited about, which is we call it our combined megawatt charging system, and it really is a system inside the box. It is a combination of switching and protection technologies to handle 1500 amps continuous with excursions up to 2000 amps for a period of time. So
I
think
like
about
that, excursions. That's
yes,
great.
exactly. So think about if a commercial vehicle truck driver, they are legally mandated to take breaks, and in that 30 to 40 minute break, depending on what country or what region we're in, they want to try and add 200 to 300 miles of range back into the vehicle. So what that means is that you have to be running at 1 to 1.5 megawatts into the truck, particularly for like a Class 8 over-the-road semi. And so then this product gives you the ability to have that MCS connection and that big power paired with optional 0, 1, or 2 CCS connectors for the kind of the off-peak charging, or when it's not running.
Right, overnight charging with trucks is not, 11 kilowatt AC. It's still like 50
It still
kilowatt.
Has to be DC, typically, because you're trying to, charge a vehicle that might have 800 kilowatt hours of battery capacity.
Right.
You can't do that over level 2.
No, absolutely. So you would be able to essentially put a CCS connection or MCS connection, same side, similar configuration
That's right.
here.
And then it would still have the protection and switching to manage a second CCS connection on the opposite side of the vehicle.
So smart.
So that way you can handle, if you pull into a site that doesn't have available chargers, you're not going to be able to drop your trailer or just pull around to the other side of the charger. You really have to have the ability to plug in on both sides.
Right, and we, at least in the passenger car space, we've seen multiple AC charging ports on vehicles. But I can't think of a single passenger car application with multiple DC charging ports.
Yeah, we can see it in China in some applications, and they're exploring like dual gun charging to really get that power up.
Yeah, we've seen that. But
I think what we're really going to see take over in the commercial vehicle space is a huge emphasis on this MCS plug and bringing big power in from a single charger.
Very cool. So that's all the stuff you're mostly focused on. And we've, BrakeTor is a really cool product that I'm familiar with. The fuses, the switching, all of that. Eaton's core specialty.
That's right.
But there's also some other cool stuff that's going on over here, and this is the stuff I want to learn more about. Bus bars, connections that seem so basic, but if you get a connection wrong, if a bus bar fails, for example, overheats, like this could take out a whole car.
That's right, yeah. And so what we'll do is we'll hand you off to some of our colleagues in the Power Connections division, and they'll teach you all about it.
Great. Well, thanks, Mark. Appreciate the time. That was great.
Thank you.
All right. Well, thanks to Mark for the tour on all this stuff. This is Joe from the Eaton, Power Connections?
Yes, sir.
Thanks for joining for the video. Really appreciate it.
Yeah, thanks for having us. Thanks for making the trip.
So this is the stuff that I see sometimes when we go to trade shows, and Eaton has them on display. And it seems so basic, some of these connections, but you were just showing me some really cool tech that's going on with these connections. Maybe you can just give us a highlight of some of the stuff that Eaton offers here.
Yeah, sure. So for our product line, we have 3 different products available. I'll start with the simpler ones, then work to the complex ones. So the first ones we do have been around for a long time: standard eyelets and stamp battery terminals. So you see these on almost every ICE vehicle out there today. Pretty standard product, been out there about 50 years or so.
Yeah.
The next phase is bus bars. And so this is started getting bigger and bigger with electrification. So we've been working on thicker bus bars, different materials for bus bars, different insulations for bus bars as they become more prominent and necessary for different modules, whether it's inverters, DC-DC converters, batteries, anything like that.
Yeah, so what would be the different materials you would use? Because I'm very familiar with a copper bus bar, similar to this, I would imagine, with some insulation around it.
Yep. So we looked at copper, we've also looked at aluminum. Aluminum's a big weight savings. So a lot of the different customers investigated aluminum. The downside to that is obviously less current carrying capability, but there are trade-offs there, especially with weight. And EVs, making the vehicle lighter gives a lot of benefits for them, gas mileage, other things that they were looking into.
Right, okay, interesting. And then you've got connections as well.
Yes, so then the final piece, probably the most unique for us, is terminals and connectors. So essentially anything going on a wire harness, kind of the third piece of the puzzle. And so our terminals are unique out there. They utilize a patented technology. They're called the high power lockbox, HPLB. And what's unique about them is the way the male terminal and the female terminal interact. So your standard box and blade, it's actually the male side that goes inside the female. The contact beams are then pushed outwards. The downside to that is at high temperature, high vibration, severe environments, the contact beams relax and you lose contact. Our technology does that in reverse. So the male goes into the female, and instead of that pushing out, losing over time, you actually maintain it. And then on the inside of our males, we have a steel spring that provides the necessary contact to push back out and maintain over the life of
Yeah, that's a really cool connection. I can't say I've run into one of those in my experience, but I don't really tear down cars that often. But that is really cool.
Yep.
And I've never really seen something like this. And so this is what you would consider 8 connection points on this one?
Yep. So yeah, so there are 3 main terminal families that we have. You're looking at the square SQ. We have LP. We call that low profile. It's a rectangular shape. You can see the difference there. And then we have the round terminals. So those are actually on partnered with the DC-DC converter team here, and they're a round pin, basically the third kind.
And we have a channel, for example, that works on like old EVs, trying to keep them on the road. So, you know, in 10 years time when those need service, or 15 years from now, our buddy Alex is going to find connections like this throughout the vehicle, potentially. And these would feed things like AC compressors, onboard screens, or
yeah.
what else?
So the SQ8, so that one is launched today with Ford. That is feeding essentially high current, low voltage battery output. So main power provided to the vehicle comes through that connection. RD8, the round, is again on a DC-DC converter here. And then we have one of our smaller terminals, what we call the Mini, is actually a lot bigger than a lot of other terminals, but to us it's small. That provides accessories, so things like your onboard charger, low charging capability, electric heater, electric air conditioner, those types of accessories on the vehicle.
Very cool. And we'll leave linked down below, but I'm sure there's a catalog of all the stuff that you guys offer. So that'll be in the description if anyone is at home wanting to learn more about cool stuff like this. Well, thanks so much for taking the time to show us around this.
Yeah, thank you for having us.
Guys, we got some cool stuff over here. This is my buddy John. He's responsible for e-mobility testing for Eaton. And dude, this is like my world over here. You got to take everyone on a tour because this is so cool.
Yep, it's kind of our playground. So what you saw earlier with the products, we get to play with those products all the time, and not only learn how they work, but understand how they work at a core level, and then how to test those products. So in front of us here is like a power distribution unit tester.
Yeah, dude, this thing looks insane. What is this?
It's very complex, but it allows us future capability. So the first product we tested on this was this fuse box, basically. So we have multiple inputs and outputs. So battery coming in and then auxiliary out to the vehicle. This whole MUX assembly picks and chooses which path we're going to excite during like an environmental test. That stresses all the components with high current, low voltage. Current's really what erodes those connections over time. Heating,
interesting. Yep.
Heating is really what we care about. Yeah. So what you see here is the interconnections inside the MUX, but then we have these probe leads. Well, we can tap off and measure at the actual bus bar of the tester, or we can bring it all the way out to the connection interface. So if we only want to get the resistance built across this path, then we can do that.
Very cool.
But yeah, the design of this is meant for something small as this, but also as large as our PDU.
Right, this thing is juicy.
Yeah, so this will go in a Class 8 truck, and we have multiple battery inputs, multiple auxiliary outputs, and so...
Right, so this would be your main battery connections then?
Yeah, and actually I think some DCFC, so DC fast charging. Yep. And then like AC cabin heater, compressor, any sort of onboard electronics you need to power through this.
It's basically like a high voltage junction box, but massive.
Exactly.
Yeah, very cool.
So,
and did you develop this box? You can't just go and buy one of these, right?
Right. So we developed this in-house with our friends over in Poland. They do a lot of this product.
Oh, cool.
And so it was a joint collaboration effort to develop this tester, sisters of this tester, and then multiple other types of testers we'll see in a minute, to support all the different products that we have in Eaton.
And that's really what we're going to be getting into in this segment of the video is like, how do you absolutely abuse your products before they go into serial production? And make sure that, you know, obviously an automaker is going to do a total vehicle check and durability testing, mileage accumulation. Before the products even have to get into the vehicle, you guys have to test these at the component level. And that's what this whole lab is all about.
Yep. So shake it, bake it, run it up in temperature, down extreme highs and lows, right? And so we can control all of that with like a thermal chamber with this test rack. So it'll take executive control of the whole setup, emulate the vehicle, emulate the environment, and everything in between.
Well, let's go see some lab space. Let's go check this place out.
Yep. Over here we have our like ultrasonic welding setup. And earlier you saw a connection like this, right? Where we have a terminal and a cable. We have to weld it together with sound. And so what we do is we put it into this machine, and it accelerates the sound, and then basically just vibrates the two with sound, causing that weld bond.
No way.
Yep.
That is so cool. That's a wild looking weld.
Yeah. It's like perfect weld, so there's no resistance between the two.
Interesting. That's super cool. And so that's what this whole machine does, basically. Yeah.
Yep.
That's
So
neat.
we'll start with something like this, put a terminal on there, weld it together, and it creates a great connection.
And then out the other end is this.
That's right.
This is so freaking cool, dude. And then you've got your, square 8-lug connection on
Yes.
that one. Okay.
Yep. And then over here, same thing, just smaller style connectors, like as you saw before. This is our mini connector. Same story, but a smaller package.
And I think also, just to reiterate, this is not the manufacturing facility of
No.
these. This is the hardcore testing lab.
Right. So we'll do small prototype runs of like a new concept, and then we'll immediately bring it over to the lab and test it,
Yeah, very cool.
provide samples to our customers, and so forth.
Nice. Yeah, this is sick. Speaking of durability testing, things exist out in the real world.
Yeah.
So like you mentioned, sound, heat, but also external elements like salt on the roads.
Correct. Yeah, we're in Michigan, and there's salt always on the roads in the winter, so we have to emulate that as well. Put our parts in this Q-Fog tester and basically spray it with a spray bar here, or just have this fine mist that mists the part. So also, like if you live near an ocean, that's
Yeah.
a big concern for OEMs.
Yeah, I guess especially in the truck space, you're going to have a lot of port-related electric trucks going through.
Absolutely.
And so, yeah, salt becomes a real situation. So that's really cool. That's neat.
Yep. We've had some gnarly setups in here.
Oh, yeah. Nice.
More to come. And then, every car is going to go through like a high pressure wash, touchless wash station.
Yeah.
So we'll put our parts in this high pressure spray environment.
Worst case scenario.
Yeah, absolutely. I mean, you got 4 wands all pointed at one
Yeah, dang.
sample. And we want to make sure that those like high voltage connection interfaces aren't allowing moisture in, because that's going to cause havoc on your high voltage electronics.
So when you send a part through, will you send it through like hot and cold cycling in the other room, vibration testing, then bring it back here and just keep it going throughout that?
Yeah, some parts will go through multiple tests as like a life cycle of part. Other parts within like the same test plan will go through just vibration or just an environmental cycle with power applied.
And the testing that's done here, is this mostly dictated by Eaton, or is it mostly dictated by the automaker that's purchasing the component from you?
It's an agreement. So like Eaton product engineering team will agree with an OEM on what plan to run, what test plan to run. And that will point to ISO specs or standards in the industry to kind of align on that strategy.
Very cool, very cool. Well, there's some crazy machinery happening over this way as well. And so what type of components would you run through these test setups? So we already discussed, power distribution units, or, what is it called? High voltage junction boxes that I'm familiar
PDU,
with.
a power distribution unit. So like over here again, this part we ran through, or not this exact part, but a part very similar. We ran multiple of them through the Q-Fog. And what we would do is cut off the cable and pop the end of it so that no moisture can get in where we don't really care about the cable, and we just care about this interface.
Right, you're
and our
caring
part.
about this connection
Exactly.
right here. Yep. And do you guys make these connections, or are these from a supplier of yours?
This is for this part. These are supplier samples, but we do also have the Power Connections business group within Eaton that is working on high voltage, interconnected, like lever action.
Right.
These are pretty hard to undo sometimes, but lever action connection interfaces. Yeah.
Right. That's pretty sweet. Yep. So more to come maybe from the Eaton Power Division.
Yep.
Yeah, that'll be neat. And then you've got all of this lab space over here,
Absolutely.
which is super cool.
So fully functional, environmental testing. We don't have like EMC, EMI testing here. That would be done at an outside house, test house. But like in here, we have our one vibration system. And this system is not only vibration, but also environment. So what we have...
Dude, this thing is crazy. I don't even want to know how much this costs, but it's got to be insane.
It's very expensive. But it gets us rocking in here. Like I don't sit very far, and I'll feel it in the floor of the building.
Wow.
We're running a really intense profile.
Okay, cool.
And then
So all of these are like hydraulic and electric actuators to make this thing vibrate at a set frequency.
Yeah. So
and
this is an
amplitude.
electric motor
Okay,
that
yep.
just pulses the whole table, and has like a certain, we'll program it to a certain displacement and a certain profile in a frequency to like just jostle the part.
Yep. And then all of your like, sensor data acquisition goes in through that port, I guess.
Yeah, these are all like accelerometers where we can see how much is the table actually moving. And then the table itself has that feedback loop. And how much have I moved in like super real time, really finite control scheme. So it will accelerate and decelerate the part to an exact profile.
Wow. So you could put like brake tour in here, for example, and just simulate a vehicle life cycle in maybe a few weeks?
Yep, absolutely.
Wow.
So we'll do like the X direction, the Y direction, so we can rotate this whole thing vertical.
Oh, wow.
This whole chamber picks up and over, and then back down.
Oh, yeah. I mean, I guess you can see even some of the connections over there are on that ribbon.
And that's on rails, too. So this whole chamber can come over on the rails.
Damn.
And then back down on the test article. And then we'll bring it back to this orientation for the Z. And then so basically we'll start the parts out like this, and then in X, and then we'll do Y, kind of going up and down, and then Z will just rotate the part this way, and then get that last axis.
Dude, this thing is so freaking crazy.
Yeah, and then of course we've got like another test system that supports the parts that we're powering and monitoring in real time.
Right, so you'll actually have the parts going through their functions through this test.
Yep, absolutely.
Very cool.
So like a typical profile we'll run is the automotive standard is bring it down to -40, allow the part to settle. So you've had your car outside overnight.
Yeah, in the worst, coldest, Alaska
in
winter.
Like Siberia, right?
Yeah.
And then turn the part on, and then immediately start to ramp the chamber up. And so that emulates like the vehicle engine compartment heating up, but also the part is active in creating its own heat. And then we'll wait, we'll ride that whole curve all the way up and get to 85C.
85C.
Yep. We'll continue to run the part and then cut it off and do it all over again.
And just heat cycle the crap out of it.
Yep.
And with vibration.
Absolutely.
So it's basically like start the car, Siberia, wide open, rip on it, get it super hot, and then deep freeze.
Yep.
That's amazing.
Yep.
Oh man, that's basically like our job before we get the cars.
Right. Yeah, we just get to we have to play with the subcomponents, like all the products you saw before.
Yeah.
Some of them we have tested here. Some of them I'm really excited to get in.
Yeah.
So we can get our hands on it and play with it some more.
Yeah, dude, like 1500 amps through the biggest vibration setup would be, 1500 amps with -40 on this connection would be hilarious.
Absolutely. Yeah, we've done 1500 amp tests, but like in one of these chambers.
Right, so these are all thermal chambers.
That's correct.
And there's different thermal chambers for different tests. Is that how that works? Or just different times of which you bought the units? Why are they all a little bit different?
So we have 4 of these temp humidity chambers, and they're really good at not only the accurate temperature control, but humidity control as well. So in here,
bus bar testing,
we have bus
it looks
bars,
like.
So
Dude, who would think a piece of metal would need testing? It's so cool.
But we're really interested to see what happens between an aluminum bus bar and a copper bus bar. Because a lot of OEMs right now are shifting to aluminum in vehicle.
Right.
It's a lot cheaper, it's a lot lighter. So both of those things are great.
Right, so this would be a smaller component but more dense.
Yep.
So I guess these would both carry the same amount of current.
Yep.
But that's the size difference.
Exactly.
That's cool.
So we have these all connected in series. So we just pass, like, for this test, it's like 300 amps.
Oh, wow.
Run 300 amps through this entire connection series, measure the voltage drop across this interface to see how much resistance is being built up here.
Wow, cool. That's amazing. And you're doing it at -40, then +50.
With humidity also in the mix. Because humidity also, you get that moisture in here, it's going to corrode. And dissimilar metals, they don't like to be touching off on each other.
Right.
But aluminum and copper has been proven to be an acceptable interface.
Okay. And how long would a test cycle run in something like this? Would this be a 1-week test? Or?
It really depends. So right now, this is like a concept validation phase. But once we put that concept in a brake tour or a power distribution unit, then we would run the whole assembly together in like a more refined profile. That's like a lifetime profile.
Okay, very cool. And lifetime profile is dictated by the automaker who's purchasing that part.
Yep.
Very cool.
Additionally, we have things like thermal shock, which is like you're in your garage, it's warm, we'll bring it up to extremes, 150C.
Okay, this is a real warm garage.
Yeah,
I think your house is on fire.
Yeah, but then we'll immediately plummet down to -40.
Okay.
And so it's changing at something like 1 degree per second.
Oh, wow.
And so it's a really quick
So within just a couple minutes, this thing is frozen to baking.
Yep.
That's crazy.
That causes a lot of havoc on things like plastics, for example.
Yeah. That's very cool. You got chill boxes around. This is all super neat, dude.
Yeah, so, and then here, we're setting up for a test, but essentially we run and find how much can a current carrying conductor interface handle in terms of in current. So for this test, this previous test data, but we ran it and we just increased the current a little bit, increased it a bit more, increased it all the way up to the point where one of either our millivolt resistance went too high, or the temperature rise over the ambient temperature was too high.
And so this is where you can dictate like boost modes for certain components, where you can say like constant, nominal current rating for something would be X, and it can handle a boost of whatever for 40 minutes.
Yeah.
I guess this type of test would characterize that.
Right, so the OEM would take that part in that connection interface and know exactly, okay, how long can we boost for before we have to start derating.
And there's always a margin of error in there somewhere, some safety buffer.
And so something I want to highlight here as well is our software approach in the lab. We use like the same sort of software for most of our test stands. It allows us to be very flexible. It's kind of like you hear in the industry, like a software-defined vehicle.
Yeah.
Well, like I try to incorporate some of that in our testing approach. So like software-defined testing. We can use this software here, add in a data acquisition device, power supply, and really the test sequencing automates everything for us. But we can also run it on a tester like this one, where we're testing fuse boxes.
Oh, cool. That's freaking awesome.
Yep. And these are like charge module fuse boxes. So your level 2 charging.
Yep.
But we can use an AC power supply instead of a DC power supply, and some AC loads as well.
Oh, interesting.
But not a lot of time to reconfigure the software to be able to run. So it's kind of like in, like let's say like Rivian, they can use a very similar software stack on multiple vehicles.
Yes.
Well, we like the same approach here.
Yep.
We can use the same software stack on all of our testers, and then mix and match like power supplies, data acquisition
it can
profiles,
handle all of that, and then you can just configure. Okay, this goes there, that goes there, and this is for that.
And then we can like edit a test sequence,
cool.
give it a sequence ID, and just go through the whole, automation profile. All of our technicians are very familiar with this too, so they can configure it themselves.
And you guys developed this software then?
Yeah.
That's really cool.
This is my baby.
Really? That's amazing,
Yep,
dude.
I built this
Congrats.
software, and I love it. It allows us to be very flexible and just accelerate the time it takes, or reduce the time it takes to get something like this up and running.
Right.
And not have to write up a new script every time.
Well, that's something we've been in a few labs, and it's like, well, this is a 2-year-long project to define the testing, develop the software, get the routine. Here, I mean, it looks like you could get this thing up and running in just a couple days.
Absolutely. The biggest lead time is setting up the equipment and then the test samples.
Right. So not even the software side.
Right. It's all the probes, all the leads, the nuts and bolts of it. The software, it's pretty simple to set up or reuse an older profile.
That's really cool. This is amazing.
Yep. So we'll just go into the analysis lab now.
Yeah, that'd be great.
So this is where we'll take apart, tear it down,
And so when
and
you're
look
saying,
inside, basically.
So this is after the components have gone through their testing, you'll actually go and pull them back open and see how internally they've fared.
Yep. So, like any lab you'll see, we have like a solder station,
Yep.
inspection stations.
Yeah, so this is all, and you actually have like a whole metallurgy like analysis for failure somewhere, and we'll go into that later on in this video as well.
So, we use torque guns just like they use in manufacturing to run like a torque to failure test, or how much torque does it take to disassemble this part after it goes through an environmental test.
Right, and there's, I guess, an acceptability level.
Yep. There are limits on everything.
Yep.
So here's a running test.
Okay,
This is that fast transition. It's actually transitioning right now.
Oh, dude, that's like insanely fast.
Yeah.
So
it's not like you just get out of your garage like immediate, but those components aren't getting exposed to the immediate environment, like the outer body of your vehicle.
Totally.
And so this is faster than
anything they would see.
Yeah, exactly.
Yeah. And so this is going 100 times this, whatever profile they have here. So minus 40 to plus 125, 100 times, whatever components. Do you know what's in here?
Yeah, it's a BDU.
Oh, okay.
So
cool.
like what we were seeing out there, a battery disconnect unit.
Yep. So it's just getting ramped up there.
Yep.
And how much power does it take to run something like that? It's got to be huge.
Yeah, it's like a 480 volt feed, and it's probably rated at 70 amps.
Okay.
So it can draw a lot of power.
Yeah, it's like a DC charger then.
Yeah.
Yeah.
Another classic feature of a lab is an X-ray machine. So we'll look inside the part, we'll look underneath solder joints in between like a ball grid array or something like that. We've seen a lot of use for this, not only for e-mobility products, but also for valves, for anything we can fit on this table. So we've done a lot of work with it. It's very useful.
Cool.
Very useful.
Very cool.
Again, another current
more
style.
testing on aluminum and copper bus bars.
Those ones will be on Vibe.
Okay, cool.
This is the same setup out there, but we ran this test a little different from the one out there. This one we ran 1,008 times, cycled 100 amps on and off.
Okay.
And so it's just stressing that interface, but we're also seeing the same thing. So
yeah, there's your 100 amps on, off, on, off. Yep.
So we'll look at rise over ambient temperature, and then we'll look at the millivolt drops at each of those parts.
Wow, so tons of data coming here. And these are all, again, those connections that we were seeing earlier.
Yep, that's the mini.
Yep, very cool. Dude, this is sick.
Yep. It's our playground, for sure.
Yeah, that's amazing. Well, thanks for showing us around all this.
Yeah.
You got anything? Oh, you got some more cool stuff back here? I guess.
Right, so this is an inverter test cell. It's like an end of line test. So we'll basically emulate the same thing that the production end of line tester does, but we can run a part in this cell and really dive into the CAN data, really allow our software developers to come in and fine tune the parts.
Very cool.
There's some work being done over here as well.
Yeah.
Last thing is our pull testers. So those components you saw earlier, we will pull them to failure.
Oh, interesting.
So we'll pull it until either the cable or the connection interface breaks. And typically we see the cable break first because our connection interfaces are so great.
Of course, yes. That's cool. So this will actually measure the exact pull force.
Yeah. So I think I have to have this closed for safety reasons.
Yep.
And then I can jog it up and down. I think. Maybe I need to do something else with the safety system. I don't remember.
Yeah, that's all good.
Yeah,
it does the thing.
It'll pull it apart gradually, but we have a very finite measurement on the force that it takes to break that connection.
Very cool. Well, I can't thank you enough for showing us around these labs. This is just such a cool sneak peek into, the components before they go into our cars. We never get to see stuff like this.
Yeah.
And this is a really, really cool peek behind the window, if you will. It's really nice. So thanks for the time.
Yeah, absolutely. Thank you, Kyle.
Continuing on with the tour, this is my buddy Kyler. What is your exact responsibility at Eaton?
Yeah, welcome. So Kyler Daly, I'm a senior manager for facilities in our global testing.
Amazing. So you get to oversee all of the cool stuff.
Yeah, that's right. That's right.
We're kind of going a little bit back in time, but also still with the present. Eaton is, of course, known for differentials, superchargers, valve train. What else in combustion cars? So many different sub-level components.
Yeah, those are really the big categories, and we support all of those out of the Marshall site. So Marshall's a little unique within our mobility group, and that we almost touch every single product that we can test or have within mobility.
Right.
With the exception of some fuel that we do out of our Southfield office, we've done a lot of the validation related work. A lot of that starts from prototype building. So that's where we're at right now is our machine shop. And this is where we can start from that prototype level, machining components that go into subcomponents that we sell as systems or, raw components themselves.
Right, so gear sets, valves.
Yep, so we do a lot of valve and valve train related components out of here from the prototype perspective. Gear sets we don't do as much, and we can show you some parts here in a little bit.
Yeah, let's go walk around this place. We've got so much ground to cover.
Yeah.
So we've already gone through the e-mobility specific applications, but still differentials are in all cars, dude. They're electric and combustion, so a lot of this is just general car related engineering topics.
Yep, for sure.
Yeah.
For
So this, what is the, I mean, already there's a million machines we're going to see, but each machine's like multiple hundreds of thousands of dollars, like insane money going
There's a big capital investments for sure, right, over time. So this area that we're in right now is our grinding area. So this is where we can get very, very technical and those really close specs meeting the prints that we need, especially when you talk for superchargers, valve components, it needs to be, right on.
Yeah, things are spinning real fast, tolerances are really tight.
Correct.
And that's how you can dial all that in. So take us on a tour, show us what we can see around here.
Yeah, for sure. So this is our grinding area, like I mentioned. We're going to head down the hallway here. And to our left, we'll be able to see through the windows. You might be able to poke your phone over a little bit, is our measurement area. So this is where we'll take the components that we build and create and prototype in our machine shop and make sure that they're meeting the specs and the prints that are needed. So we have some CMMs in here to do some of that measurement.
And the CMMs are those like millimeter perfection or micron perfection little probes.
Yeah, so there's probes, so we can load in a CAD file of the part that has the tolerances built in. And then the CMM will use a probe and go around and check various points within that to make sure we're meeting the specs required.
Super cool. I've once been in like a transmission clutch manufacturing facility, and I saw one of those at end of line that they would pull like 1 out of 100 out or whatever it would be and just double check. And you're doing that with like all of the prototyping components, I would guess.
Correct. Yeah. So from, again, raw component levels to even sub-assemblies, we'll do various checks on the measurements before they go on test, which we'll show in a little bit.
Cool. And then you've got this sort of trophy cabinet, can we call it?
Yeah, that's a good word for it.
This is some of the stuff that you guys have produced out of this facility, and some of which Mark, who we met earlier, holds patents on, which is really cool.
Yeah.
And this is neat stuff.
Yeah, so this does a really good job of showing just the level of complexity in control that we have within our shop. So everything from supercharger housings, again, from the prototype side of things, these bores need to be very exact, especially when you talk about that rotor and spinning at high speed. We need less or zero tolerance as far as clearance and leakage, right? So that's a critical one, and we can hold those on our machines here. Everything from prototype, inverter housings that we've done in the past, all the way up to, we get into more of the valve train related components. And again, you mentioned the history. This is where a lot of the meat in Marshall is around our machine shop. This does a good job of kind of showing how from raw billet, we can take that stock and machine out, in this case, a rocker arm component. So again, this is not manufacturing, so it's going to be much lower volumes, but we'll be able to go in and do a lot of this high complexity prototype build here so that we can do the testing and work with our customers.
Very cool. Love to see all this. And you've also got some like heat treatment that you can do over here as well, and some other things I noticed.
Yeah, we have our own internal heat treat capabilities. So again, with lower volumes, we're able to do some of that in-house, which helps save a lot of time. So one of the biggest flexibilities and assets that the machine shop does for us in Marshall is allows us that quick prototype capabilities. So whether we're rapid prototyping a component to go on test, or even fixtures to help hold the test component in the labs, we can support that out of the machine shop here.
Very cool. Very cool. This is awesome.
Yeah. So we'll head this way and we'll show you some of our valve train component testing.
Yeah, would love to see it.
All right, so this is our valve train lab here. So we do everything from characterization testing all the way up through durability. So these test cells that you see on this wall here, this is really our performance test cells. What we're testing here is components within the valve train assembly. So a lot of rocker arms, hydraulic lash, those types of things related to the products that we sell. So in here, we don't actually burn diesel with engine testing. We have electric motors that are underneath these stands that will spin the valve train components. And then we go through and instrument the whole setup so that we can collect all the data, analyze the data, monitor the test while it's going. So some of the cabinets that you see here are all internally designed and engineered. And what we do here is if you think of a valve component and going up and down in an engine, over a durability cycle that may be 300-400 hours. There's a lot of data that's collected there. And we need to be able to know what the valve lift and drop and timing and all of that is. These systems allow us to set parameters and flag when there's issues when those go out for each of the valves and each of the valve events.
So maybe you can just at a high level speak to some of the work that Eaton's doing and maybe the money of the industry. It seems like passenger car applications have moved a little bit away from combustion. Of course, we cover the electric thing. A lot of the R&D team money from automakers is going straight to electric. Maybe hybridization, terrible name, but maybe hybrids.
Yeah.
But at least in the heavy duty space, diesel is still king when it comes to long haul, over the road stuff.
Yep.
So is that where most of your combustion testing is going?
Lately, yes, has been mostly there. So Eaton's nicely positioned because whether it's e-mobility and going strictly BEV or ICE or in between like the hybrids you mentioned, we're kind of been playing in all of it. So yeah, the hybrid pieces we do some testing. It's more for like cost out types of projects for passenger vehicle. Most of the new development and testing going on is more commercial based though.
Right, makes sense. So you've got a bunch of labs here to run.
Yeah, there's actually 7 test cells here that we have for performance, and then we can't see them right here, but back through the hallway there, we have 8 durability cells.
Wow.
So that's where we can set an engine on and just let it scream for 400 or 500 hours.
That sounds awesome.
Yeah.
That's pretty cool.
Yep. Yeah, the walls are actually sand-filled brick, so from the noise and sound perspective,
yeah,
it doesn't impact the rest of the campus as
wow,
much.
that's pretty cool. Yeah, I'm noticing how nothing's running right now, but
yeah,
it is dead quiet.
Yep,
yeah.
It is. Yep.
Very
All right,
cool.
so we'll go from here, and I'll show you some of our commercial dynos. So we're not going to go super specific, but give you a high-level overview.
Yeah, that'd be great.
So we have 3 test cells, or 3 dyno cells here. 1, 2, and 3 at the end. These 2 right here are really focused on commercial valve train testing. We have the ability in these dynos to actually burn diesel. So we have diesel tanks outside, and we can run diesel in and actually run and fire the engines with the correct emissions going out. We haven't done that much lately. The OEMs have been handling more of that testing directly. We're handling more of the valve train components again on the commercial side, so we'll use an electric dyno to spin that whole valve train. Again, not going into specifics, but we do have full engines on test here. So we're having to go through all the controls on the variable geometry turbos and all of that within the systems to make sure we're testing correctly.
Very cool. Thanks for showing us.
All right, so next we're going to go into our material analysis lab, so our metallurgical lab. In here we have the ability to, at a high level, really do failure analysis. So the fun part of our job is we're purposely trying to break stuff, right? So when it breaks, we want to understand how and why it broke. In this lab, it lets us do that at a molecular level. So we're able to take samples, cut them down with the bigger saws that you see here, provide pucks like you saw earlier with the powered connections team, polish those and then review those in scanning electron microscopes and other high-powered devices to see how that failure started and how it propagated so that we can feed that back to the design teams.
Very cool. Yeah, so real nerd stuff happening.
Yes.
Love it. This is really cool. Do we have any examples of what those pucks look like that could go in? Because these are the microscopes over here. And
yes, we do have a puck. Yep. Yeah, thank you.
Yep.
So yeah, you can see the level of polish that we can put on those.
Yeah, super polished.
Yes, yeah. So yeah, thank you. I don't know if there's other things that we want to talk on specifically, but all this equipment is to help create these pucks and get them ready for the analysis. And then through the room here, we have hardness testers, various material type testers where we can actually do the deeper dive.
Oh, dang, I didn't even see this earlier. What the heck? This is crazy.
I mean,
it looks
straight,
like a mad science lab.
it's science lab, exactly.
And you've got valves over here, so this is really cool, dude.
Yeah, so when it comes from, again, whether we're failing on purpose components in the lab to see how they fail and when they fail, or handling warranty returns and root cause analysis, we can use this lab to really deep dive into those failures.
So maybe you can just touch on the warranty thing really quick, which is, let's say, there's a over-the-road diesel engine that fails within its warrantyable period. It comes into a service center. Those parts are swapped out. That truck's back on the road. When those parts come back to the manufacturer, they may send them to you guys and say, hey, you've got this really cool lab. Can you figure out if it was a you problem or something else and what actually failed?
Correct. Yeah. So that's exactly the process. So the OEMs will send them back, and we out of this lab not only support just the components that we do in Marshall, but we can support everything from Eaton. So we've done other product line support out of this lab as well.
And do you offer that to other component manufacturers, or is it just Eaton components?
We don't currently offer as an external service. It's something that we've been thinking about, but not quite there yet.
Okay, interesting, cool. Thanks for showing us all of this.
No problem.
Guys, you joined me over here with a bunch of superchargers on the far end and then a bunch of differentials. I think we're all familiar with the term Eaton locker in vehicles, and I'm here with Matt, who's a differential specialist, really specialist across many applications, but is going to walk us through the Eaton differential styles. We have a bunch of different, on this channel, we talk a lot about limited slip differentials, locking diffs, mechanical lockers is a term you'll hear me say often. We often reference these types of applications when we're comparing software lockers, which would be individual motors trying to match wheel speed versus a mechanical way to lock cross-car wheel speed. So Matt, maybe you can walk us through some of the different types of differentials, because what we don't see here is an open differential. Eaton does not offer one of those. This is all about limited slip and locking.
We have offered open differentials in the past, but it's just not our key focus. We like to play in the the torque modifying differential space. So anytime we can add content to the standard product is where we excel.
Yeah, very cool.
So you said you wanted to start with e-lockers?
Yeah, I think e-locker is something that our audience is familiar with. Like, for example, you could be driving a vehicle and just hit a button to lock a differential.
Yeah, so these are e-lockers. It's like you mentioned. There's this electronic solenoid on the side here, and when it engages, it pulls this plate, and this dog clutch engages to the side gear, locking the differential. So you basically lock a side gear to the diff case.
Right, and what, would you say that this is pretty common in series production vehicles, something like this?
Yeah, yep, that's the most common form of an e-locker out there in the field today. So
Cool.
We also have our collar style e-locker, which operates in a drag clutch. When the electromagnet it gets energized, it puts a drag on the ramp plate, which puts a radial force on these push rods, engaging the dog clutch.
Interesting. So basically that will push this over here. Now you've got left and right wheel speed completely locked. So that's not a variable clutch, right? That's just either locked or unlocked.
Yeah, it's 100% locker. Yep.
But then you get into variable locking forces, right?
Yeah, so we've got a couple electronic limited slip differentials here. This is our most basic one, where it requires delta wheel speed to run this gerotor pump. And then the gerotor pump uses the fluid in the axle as a hydraulic fluid, and it continuously pumps anytime there's a differential difference in wheel speeds, right? So then if we want to engage the clutch or bias any kind of torque across the axle, we will energize a solenoid valve, which stops the flow, builds pressure, and then there's a piston in here that you can see that puts that pressure on the clutch.
Oh yeah. So this is very common limited slip style that I think a lot of users are familiar with, where if you're going through an elephant step type scenario, you've got wheel speed on one side, you stay on the accelerator pedal a little bit, let this build up some pressure, and then it can transfer mechanically torque to the other side.
It's designed and sized to basically build pressure immediately.
Okay.
Anytime there's a difference in wheel speed, you'll have pressure to work with.
But it still requires differential wheel
Still
speed
requires
to get it
differential
going.
wheel speed, yeah.
And
So
then this looks crazy. This was actually in a series application up until recently, which is really interesting.
Yeah.
So this is, explain what's going on here.
yeah, we'll get back to the gyro disc. The clutch is always sized to pretty much provide 100% lock also.
Okay.
So we try to size the clutch and the hydraulic system to provide skid torque type torque. So it's essentially a limited slip, but it really provides enough torque to lock the axle. And both designs do that, are sized that way. This design is preemptive, so we've got a motor operated pump that builds pressure and stores it in an accumulator. And anytime we want pressure or to bias torque across the axle, we will call for that pressure to be sent to the piston.
And that's what comes down here, and then essentially the same thing happens, just driven not through the wheel driving the pump, essentially.
Yeah.
It's through an electric motor.
There's a couple benefits there. You can choose your hydraulic fluid. It can be different than the axle fluid, and it's preemptive. So it's always available.
That's pretty cool. But then again, I guess the downside for the automaker would be size and cost.
Packaging, size, cost, it's more costly.
Yeah, but then of course, if you're building a really cool car that you're charging, feature count for, then the user, the buyer, could pay for something like this.
Sure, you get a lot of stability and traction benefits from those types of systems. Both of these systems can provide different levels of stability and, of course, traction enhancing benefits. So.
Yeah, that's super cool. And then there's some other diffs down this way as well that I found interesting. This was the most interesting to me, and just in terms of looking at it from a design.
This is our True Track, and it's a helical limited slip differential. No, so you kind of have to have some resistance across the axle. And these can be manipulated by brakes, or if you've got a certain amount of traction on one side. The internal gear set here is designed to provide friction in the system, so that you get the same frictional aspects of this as you do a plate type limited slip, which is right here. But when you get a biasing torque across the axle, these gears separate, and all the interfaces create friction.
So this would always have some sort of friction in it at all times, right?
Yes. Yep.
But I've noticed, actually my buddy Mark told me that this is getting more popular in electric vehicle differentials.
Yeah, and the theory there is it's durable. You don't have plates that a lot of customers are concerned with plate wear.
Okay.
Our plates wear really well compared to some of the other products out in the field, but this is all metal and
Right.
it's very durable. You have a pretty much constant bias ratio across the life of the product.
Oh, really? Okay, so even as it ages with a ton of miles,
Yeah.
it should be pretty good.
That's the idea. And with the plate type, you can polish the plates, and over time you might get a reduction in bias torque depending on the duty cycle and how the customer uses the product.
Right, and for the most part, most customers are just driving normally, but there are some extreme heavy users that could hit some limits somewhere. That diff all the way on the left, this looks more like a spring type, where it would be almost more traditional in a sense.
Yeah, so I mean, you can have springs. These are preload springs, so there's always a certain amount of torque biased across this product. But we also offer these without the preload.
Okay.
And anytime you have torque on the gear set, the bevel gears will separate and put an axial force on the clutches, providing your bias torque.
And then this is more of like a racing type clutch, I guess.
Yeah, this is a Detroit locker. I believe it's used in NASCAR and a lot of heavy-duty off-road applications. So this product is always locked when you're in a straight line. But if you differentiate, then it unlocks.
Yeah, that's
So
interesting.
if you want to turn a corner, it will unlock. So
But anytime you're like drag race mode, for example, this would lock the
Right.
left and right wheel speed.
Yep, it's always locked.
Yep, that's really
unless
cool.
you're turning a corner. So
Very neat. Well, that is a really cool education on a bunch of different types of differentials. I can't thank you enough for walking us through those.
you're welcome.
That was neat. I can't wait to go on a tour, because what we're going to see after this is how you break all of these, or at
Yep.
least test them.
Yep. And I think you're going to get to drive a few of them today too.
Yeah, that's right. We will. Very cool. Well, thanks for the time.
Yep, you bet.
So before electric motors were making big power, we had to go combustion, of course, and then you had to do some forced induction. Eaton is famous for superchargers. And I think many viewers of this channel, if you've driven GT500, CTSVs, et cetera, those are all using Eaton superchargers. So is my little Mini that I just bought. My little R53 has an Eaton supercharger. And I think you guys probably have more OE superchargers on the road than anyone.
Yeah, I agree. So one of the partnership too with Magnuson. So even if it's a Magnuson supercharger, it's got our rotating group inside of it.
Oh, very cool.
So this is a cutaway of the GT500. This is from a 2020. This shows our 2650 rotating group and supercharger. So it's kind of a cool visual to see how that's built in and set up in the package.
Yeah, dude, that's sick.
Yeah, just for the viewers, from size component wise, our ranges of superchargers, vary quite a bit. So this being a 2650, so that's 2.65 liters of displacement. We go all the way up in the aftermarket up to 3100, and then from the low side all the way down to 180.
Right.
So very big range in sizes.
No OE application of the 3100, right?
No OEs,
Well, someone's
aftermarket
gotta
only.
Step up.
Currently.
Someone's got to do it, because we need to put a bigger supercharger on everything. These things are awesome. They are so cool. They sound cool. They make instant power, of course. So that is a really cool thing. But we're going to see some more supercharger stuff today, right?
Yeah, we can actually walk right now. We'll go check out the test lab for the superchargers.
Oh, that'd be awesome. Yeah, let's run over there. And on the way, we should also mention, Kyler, all of the patents that Eaton holds, and also the employees of Eaton. They're on display all throughout your facilities.
Yeah, the Marshall specifically too, being an R&D facility, right? We really take pride in that innovation and R&D work that happens here. So yeah, this is not all of the patents by any means, but does do a good.
You can see like supercharger wheels on this one, and just other cool differential stuff. It's really, really neat.
Yeah, we definitely take pride in all the innovation here, and this is a good way to showcase that for visitors.
Yeah, that is really nice. And just the building in general, like there's a sense of like real automotive work happening here.
Yes.
I've been to a lot of factories and also automaker buildings, but when you come to a supplier, which Eaton is, to automakers, I guess you also supply the aftermarket directly, but you have so much durability testing happening here. I mean, it even goes beyond what I've seen from some automaker R&D facilities.
Yeah, the footprint alone in the two buildings that we have here to dedicated towards testing space is pretty large, right? I'd say bigger than most people would anticipate.
Yeah, totally.
So this lab here is our build and tear down lab for superchargers. So this is where we'll take everything from prototype builds to cost out projects. We can do the assembly of the supercharger here. You can see various units in the lab here at varying degrees of assembly. We'll do the testing or build them here. Down there, we'll show you we have some characterization testing. So we can do characterization and then durability testing. So that's some of the longer hour tests. We'll put them back on characterization to see how that durability may have impacted the performance of that unit. And then we can bring them back here, do a tear down, grab pictures, measurements, all of those things.
Very cool. Yeah, let's go check out some of those labs.
Yeah.
Yeah, this is crazy. So you've got like a whole wing of the building just for supercharger dynos. You can,
yes.
Is that one screaming off in the background?
There is, yeah, I think one in cell 3 we can walk past.
Yeah, cool.
So yeah, this hallway is kind of split. So it's a little bit of supercharger and then also differential testing. This cell here, we have 2 of them like this, and each one of them has 6 different test stands. So you can see the cages in there to kind of help separate them. Mm-hmm. But again, instead of using a live engine here, we're using an electric motor to spin with pulleys to get hours and spin that supercharger.
Right, so you can basically see there's not one installed right here, but that's how it could work. So you've got where the pulleys would hook up to on the supercharger side, and you just run that thing through a series of drive cycles, basically.
Yeah, depending on what the customer OEM profile is, yeah, it could be up to 500 hours that will let the thing just scream.
Damn, it's a lot of stress on components.
It is, but that's what we're here to do, right?
Yeah.
Is break stuff on purpose and see how it breaks so we can design it out.
Amazing. And then the software that you're running through all of this, is this standard off-the-shelf dyno software, or is it Eaton stuff, or how does that all look?
The software for these cells specifically was custom built and homegrown within Eaton. So a lot of the test stands that we have in our lab are homegrown. Mm-hmm. We're trying to, the vision is to try to get more standardization there. So we could flex potentially technicians from one group to the next in the ability just, to help where we're having waves within the testing.
Right, like you might get a big contract and you've got to do a bunch of inverter testing, for example.
Yep.
If people know how to operate the software, they can help run that test bench.
Yep. But yeah, historically a lot of homegrown, self-engineered software.
Very cool. Let's keep rolling.
Yeah, for sure. So we're going to switch over and talk differentials real quick. There's a nice big window right here for you.
Sick. Dude, this stuff is so cool. And what's crazy is you have like hundreds of these. I don't know how many, but there's just everywhere we look, there's just more test benches around this building. This is super sick.
Yeah, so this cell specifically is our gear fatigue cell, and there's a sister cell on the other side of this that's just a duplicate of the same thing. Mm-hmm. So what we can do here is you can see one of the outputs, we have a torque sensor on there, but it's locked. Yep. So we're locking that one output or the wheel end.
So that can't move over there.
Correct,
You've
on
got
the right.
Your engine load simulated here, or drive shaft load, I guess.
Yep, you'll have your input coming in kind of straight at us here, and then to the left here we have a 50-to-1 gearbox. So what we're able to do is drive from the input and then ramp up the torque like crazy on the output to get those internal gears of that differential stressed and fatigued.
Very cool. I'm hearing a supercharger scream over here.
Yes. So you can probably zoom in on one of the units up here.
Yeah.
That one is currently running. You might be able to pick it up on the mics. I forgot to mention with the other cell, same with this one, on the mezzanine up above, we have a lot of air conditioning units. So not AC traditional, but if we need hot, cold, pressurized air, we have the systems up above in the mezz to feed the inputs and then also monitor the output air too to see how that air is going through the system.
Mm-hmm. Because of course superchargers will lose they're very affected by air density. So if you're feeding hot air and the whole engine's heat soaked, for example, the supercharger still has to work.
Yeah.
But it can lose its efficiency the hotter the air goes. And that's something that electric cars are also affected by temperature. Inverters get hot, motors get hot, batteries get hot. I think most of our viewers probably also are familiar with combustion cars, where heat is always the enemy of power.
Correct. Yep.
So that's cool. That's really neat. So you've got a supercharger back there, another one over here. And do you know what these are actually running through in terms of test cycles?
I don't know these ones specifically. We don't have that lab manager handy currently. But from the durability standpoint, yeah, it's anywhere from 300 to 500 hours.
Yeah.
So they'll go through multiple.
Man, these things are screaming. They're like got to be 15,000 RPM or something.
Let's see, we can try to see here. Yeah, 17 almost.
17,000 RPM. Yeah, they're spinning.
Oh yeah, they're
that's
up
really
there.
cool.
They're up there.
Yeah, the mics probably won't pick it up, but if you've heard a supercharger
it's
whine,
mine.
just like all the way at max
Yeah.
revs.
Yep, for sure.
Sounds amazing.
Yeah, this is a good example of that homegrown software package too. So you can see, without zooming in too close, the different profile
already did
zooms. I think you're good. But yeah, it's a good example to show, the highs and the lows. And again, whether it's the air that we're controlling coming in or controlling going out, we have the ability to test all that and go through the different profiles.
Amazing. Cool. Love to see that.
We also have, from the supercharger standpoint, we don't use it as much here. We largely leverage our Athens plant, but the rotor coating that's on those rotating groups, we can do rotor coating in this cell. Again, from the prototype perspective, it enables us to have that flexibility to make those prototypes here.
Very cool.
All right, we'll head down the hallway a little further. We're going to start getting into some more of the differential testing. The first cell here is a hydraulic cell. There are 4 of them like this that we'll see. We can change up the setup here a little bit with each one of them, or even within the existing cells. So similar to the gear fatigue cell, we have 3 motors on this one, so 2 on the outputs and then 1 on the input. And again, we'll define and create profiles to run tests based on different customer needs.
Right.
So we can drive from the input and then provide those resistant loads on the outputs.
And from an electric standpoint, what type of testing would you say is different between a combustion car differential or an electric car differential? The differential is the same, but does the testing procedure need to change at all?
The procedures change the most that we've seen so far based on the input speeds required. So a lot of the EVs have a much higher ratio than a traditional ICE engine. One of the things too that we're further investing here in Marshall is the ability to test more EV type of differentials. What I mean by that is we need to move our input motor from not just the traditional T-shape, but being able to be modular and swing that, left or right potentially based on which customer is looking for that testing.
Right.
The architecture is not the same with each EV, so we have to be able to modulate.
Most EVs don't have a drive shaft running to the differential
Yes,
anymore.
I'd say most of them don't. Yes.
Yeah.
Yep.
In fact, we've even seen some EVs have differentials inside of the actual rotor on the electric motor now, and then have gear reduction on either side. It's crazy what is
interesting.
happening. Yeah.
I don't know if we've seen one of those yet here, but
I mean, the differential's like this big.
Wow.
And it just spins to 1,000,000. It's
very
wild.
cool.
Yeah,
Very
Lucid,
cool.
shout out those guys. It's really cool.
Very cool.
So you've got
This is
control.
this is our control center for what we call PS5. So this is where we'll do the characterization testing for superchargers. So again, after the initial build, we'll bring them on to see how they're performing. This is going to be more short-term type of tests. Then we can go back, do durability or various other tweaks to it, come back, do another characterization to see how it may have been impacted from that testing, and then go to teardown.
Very cool.
All right, I think we're going to do a little bit of walking here, and we'll go through.
Well, let's hammer down. We'll meet up with everyone down there.
All right, so this is one of the 2 measurement labs that we have on campus. This is for our admin building here. We currently have some calibration activities going on one of our CMMs. But we have 2 here, and largely out of this room will support the differential and supercharger business. We've done some e-mobility support out of here. But again, we can take that CMM, load a CAD file of a component, and then make sure it's meeting the specs in the print there.
Yeah, these are super cool. And I mean, you can just see a bunch of different gear sets that are over here as well. So
Yep.
that's pretty sweet.
Yeah, so the big thing in focus is we want to make sure parts are to print before we start testing to make sure anything that happens during testing, we know how that may have been impacted or changed.
Makes sense. Makes sense.
We'll swing through here real quick. So we have a semi-anechoic chamber
Oh, yeah.
that we can show. Traditionally, this was heavily used for our supercharger business. And if we can go head on right in here.
Oh, yeah. This is always a weird thing to go into. Best audio quality ever on an out-of-spec video right now.
Yeah. So the big box that you see here is really, there's dynos inside, similar to those durability test stands for superchargers, where we can spin the supercharger up. Again, largely lately, we've been using this room more for e-mobility type component testing.
Interesting.
So, I'm sure your viewers are well aware, but as you go to BEV, you don't have the ICE engine noise to drown out a lot of those components and things that you will now hear in a BEV.
Right. Differential noise comes in much louder, even inverter noise, things like that. Switching frequencies become more important. And so that's where you have all of these, high, I would say, very sensitive mics placed around this building, and you probably even have some inside this chamber as well.
Yeah, and we have the ability too to build an array of all kinds of mics in here to help capture whatever the specific profile is looking for.
Yeah. So all the NVH guys, this is where they live.
Yeah, we actually have a dedicated NVH team, that will base out of here too.
Very cool. This is sick.
All right, so up here we have a lot of our components for our prototyping. So, rough order of magnitude in the low millions of dollars worth of inventory up here.
That is crazy to think about.
Yeah, as we get specific requirements and requests for quotes, we'll create those prototype builds. There might be iterations too that we do internally before we supply a prototype to OEMs. So you can see some of the different component level pieces and parts here that will go into the subassembly for prototypes.
Yeah, super cool. You just got racks of parts everywhere. This is so cool.
Yeah.
Yeah, that's awesome. Thanks for showing us
Yeah,
this.
no problem. All right, so in here we have another hydraulic cell. This one is under commissioning actively. So we're still a couple weeks or a month or so away from being able to commission here. You can see some of the prints laid out. This cell specifically, we've created it to be modular to be able to handle both ICE and BEV applications. So we have another pedestal. You can see the main T table there.
Yep.
We do have pedestals that will be able to fit on either side so that our input motor will be able to swing either left or right to be able to be parallel.
Right,
to
so
one.
you could totally calibrate this however you need for the layout then, rather
Correct.
than just a traditional T.
Yeah, you can kind of see the rib thing going down the middle there, so we can move the outputs whatever width of the vehicle is going to be. But then we also have torque sensors and those types of things that are in line there.
Very cool. That's neat. That'll be a cool tech to
Yeah.
have. Yeah.
Yep, for sure. And here's just another duplicate of the same hydraulic dyno. This one does look a little different currently, just has an actual wheel and tire on the end.
Huh, that's interesting. So for inertia purposes, I guess you can get a more accurate reading with that.
Exactly. So we can spin one up and then, we can trigger that locking mechanism, make sure it's hitting when and how we want it to.
And I guess you would trigger the locking mechanism under light load a bunch of times and maybe just one giant failure one as well. And there's a bunch of different tests.
Yeah, again, trying to break stuff here too. So it's one of the fun parts of it. But yeah, a lot of it's going to depend on what the requirements from the customer are.
Very neat, very neat. And then over here,
Yeah, this is our largest electric dyno. You can kind of to peek in there a little bit. Each one of these output motors is north of 600 horse. So
Wow.
we can go up to a 12-inch differential in here. And again, very customizable as far as what types of profiles we can run. The current limitation is mostly just from the ICE side, given the T-shape that you see, because we're kind of prohibited by the bed shape or the bed plate within the floor.
yeah, and I heard they just ran a pretty long durability test on a 12-inch in here and went
Yes.
till it popped, but a million plus rotations.
Yeah, I think our rough estimate was 14 million
Yeah.
rotations on the single unit.
That's super
Yeah.
cool. That's
Yeah.
awesome.
And then through here, we'll poke through, again, some construction in progress.
It just keeps going. It's
It
crazy.
does. It's never ending.
Yeah, holy smokes.
So if you kind of get up and over the boxes, this is one of
Yeah.
our impact cells. So we'll take what looks like a bronze cylinder there. We can spin that up. It's a big weight. We'll spin that up with the electric motor behind it, and then this bigger blue box in the short or up front here is a clutch. So we'll lock both of the outputs of an axle. We can spin that flywheel up, and then we'll impact the whole system.
Right.
Whether we go same tooth multiple times, varying degrees of impacts. Again, trying to see how and when things break.
Yeah, that is super cool. Really cool. And like you mentioned, a lot of these testing procedures are dictated by the automaker before they purchase an Eaton diff, for example. But some testing you guys got to do on your own and come up with as well.
Yeah, for sure. Especially on the prototype phase of it, right? We're going to make sure we get everything locked in to be
Right,
able
and
to
here's
sell
sort
that.
of a real world application of kind of how that would work, where you're on a split mu on a hill, you get one huge wheel speed hit, for example.
Yeah.
And then you just go, unless it's a limited slip diff, if it's like a G80 locker like that would be, it would just be bam,
Yes.
you're locked.
It's going to be an impact to the system, so we want to make sure and understand how that impact is going to affect our components.
Very cool.
And here we have our HARF stands, so it stands for high angle rotary fatigue. Again, we can lock both of the outputs to the axle, and then that input motor, whether we're doing just short fatigue cycles back and forth or just ramping up the torque until things break, we can, again, do either one of those things and anywhere in between. So both of these stands are basically duplicates in each one of those motors. I think it's 270 degrees in either direction. So, whether we're doing wire fatigue for some of our e-lockers to make sure that's going to, withstand the elements and expectations, or just internal components, making sure that back and forth durability is taken care of.
Very cool.
All right, so this is one of our component level testers. It's an SAE2 friction tester. So what we can do here in that silver head you see, internal to that is a portion of the clutch pack that'll be part of our differential. So what we can do here is test out varying friction materials, different plate thicknesses, any combination of those, as well as the fluid that is going to be in there. So one of the big development pieces obviously is, going from traditional ice and diff fluid to, BEV. It's a different fluid, more transmission fluid-like. So seeing how those changes in fluids can impact the differential and friction materials.
Yeah, and fluid friction and just overall rotating, resistance becomes a much bigger issue with efficiency on electric. So
for sure,
something like that is really helpful.
For sure. Yep. And then the next cell that we have here is we don't have a unit on there currently, but it's our second largest electric dyno. And in here, again, we can control each of the motors, so the two outputs and the input to do whatever type of test that we need.
Very cool.
So yeah, in here, it's a lot of component level testing. I think Tim was just mentioning, not sure if it picked up on the mic. So in here, it will do, again, different parts of the diff. We can test out those individual components before we do the full subsystem or full system testing.
Very cool.
And then just a peek in this room real quick, this is our differential build and teardown lab, similar to the Supercharger Lab that I showed earlier. And then here's one of the internal differential gears we were talking about. So you can kind of get a feel for how many teeth and the size of those. And then through here, we have our garage bay. We have 5 different lifts. There's 4 that we have immediately here, and then another one through the double doors at the back. The vehicles are missing up here. They're in the back. We'll see that in a different video, I believe.
Yep.
The Silverado over here, this is a good example of kind of, big picture for the proving grounds. It has the torque sensing and speed sensing capabilities on each of the rear wheels. And what we can do is we could take this out on the track, run a certain profile, collect all of that information, the torque, the speeds on a time basis, come in and then implement that on a test stand. So then we can take, if there's a specific maneuver that we want to be able to test, we can repeatedly run that without that human factor on a test stand.
Right, you can just run, you got to get the data once and then you can run it a million times.
Exactly.
That's really cool. So this was a really great tour inside of all of durability test prototyping labs. We'll have plenty of other content coming here at the proving grounds, driving stuff, looking at different surfaces. We're going to do a tour of all the surfaces as well.
That's right.
And so, Kyler, thank you so much for taking us around here. This was a great video. It was cool to meet some of your colleagues as well. And I think this was definitely on the nerd level, way up there, which we love. So This was great.
Yeah, I think high level, there's roughly 170 folks on campus, and 70-80% of that is engineering or technician based.
That is super
So we like to nerd out on the engineering stuff here.
Amazing. Well, shout out to you for hosting us. Thanks to Eaton, of course. And we've got more videos coming with actual vehicles on this channel and the others, which I'll leave linked below. So thanks again, Kyler.
Yep, thank you.